So for this, we are taking a look at section 2.7, solving linear inequalities, and then we'll also be getting into working with our interval notation and what that looks like once we get a bit farther down into that part of this chapter or section for today. So linear inequalities are very similar, but at the same time very different from linear equations up to this point in time. Linear inequalities are going to have a range of answers rather than just a single answer at this point in time. So up till now, we've done addition, subtraction, multiplication, and division with equations, and always gotten an answer down to be something like x equals a number, y equals a number, n equals a number, and so on. Well, as we're going to see now with inequalities, we're going to have ranges of answers, meaning we're going to have a whole big, long, giant list of these things. And we're going to find that some of our properties, some of our methods for going through and working with these things is going to be very, very different in that regard. A lot of it stays the same, but there are some very subtle but important differences between how we solve each of these. So before we get to that, though, we're going to go through our 4 types of inequalities. And the ordering and the way that these are facing absolutely does matter. So we have greater than, less than, greater than or equal to, and less than or equal to. Again, the subtle difference between these is having that little underline with them to tell whether it's greater than or greater than or equal to. So make sure you are keeping track of that, because that's very important for when we're going through and writing out our answer, and if we have to, working with number lines and how we write out our answer. So again, 4 general types of inequalities. And we're going to jump into working with and looking at these things on a number line. I think that having a visual of these inequalities is very, very, very helpful. So to work with a number line, we do have some requirements for creating these things. And I'll go through an example of it here with these two. So our requirements for creating a number line. We need to define where 0 is, because it's going to be showing up in these things, and we need to know where our positive and negative ends up being. It's kind of like we have here. So we need to define the positive and the negative directions along our number line. And I emphasize this because a lot of people, when they are writing and drawing out their number line, they'll say everything to the right of 0 is a positive, and then everything to the left of 0 is also positive. And it begs the question, how do we get negatives then, or where do we put negatives down on this thing? And the answer is, if we have it set up that way, we can't, and we get wrong answers. And then last but not least, we need to define the scaling on the axis or on the number line. We have those little, excuse me, have those little tick marks showing up, as it were. Am I counting by 1s? Am I counting by 2s? Am I counting by 5s, 10s, etc., etc.? So we need to define those for ourselves. Now, when we are working with a number line, we're going to be using and plotting these inequalities that we have been given and that we are working with. And again, we'll get to these examples here in a second. So if we are working with greater than and less than, this corresponds to using a parenthesis on our number line, meaning we are going to be excluding that particular point that we're going to be working with. You can also write this in. It depends on a different form of what a program might show or what an instructor will allow, which I'm okay with you doing this. You may also see this as an open dot or an open circle on the number line. So if you're going to use parentheses, that works fine. If you would like to use an open circle, that works fine also. And again, I'll illustrate both of these as we go through our examples. If we're working with the greater than or equal to and less than or equal to, these correspond to using brackets on our number line, meaning that we are going to include this point. I need everything less than that number or equal to that number, so I can use that in my final answer. So similar to our greater than, less than, this has an open point. If we are going to use greater than or equal to and less than or equal to, we are going to have a closed point. It's just a regular little dot that's showing up on there. So when you are plotting these, you can either use the bracket or parenthesis, or an open dot, or a closed dot. Just depends on which of the inequality types we are working with. So you absolutely need to make sure that you have an understanding of which one of these that we're working with, which one represents what. Again, if you need to come back and reference our types that we have up here, absolutely do that. I expect you guys to be using and referencing these notes or the notes from the textbook. There's nothing wrong with that, so please be sure that you are doing that. There's nothing wrong with it. So let's go into a couple examples of this. We're going to go into graphing the following on the number line, and then we'll write our answer in interval notation. So we'll go into the interval notation here, probably once we get into it right down below here. It'll be a nice segue in. So these are the two examples that I'm going to reference on our blackboards. We're going to jump over and build these number lines and then plot these answers. Okay. So our first example that we have been given, let's leave this aside here a little bit. There we go. So the first thing we've been given, we are told x is greater than -2. So I want all the values of x that are greater than 2, greater than -2, I should say, and I want those plotted and filled in on the number line. Okay. So creating a number line, again, this is what you have to do for every single time you're creating one of these things. It's a preliminary step. You have to do it every time. So writing out our number line for ourselves. Define 0. So I'm going to let 0 be right here. Define the positive and negative directions. Okay, so I'm just going to put a little positive over here. I'm going to put a little negative over here. Great. And now I need to scale the axes. So if I'm looking at this thing, I've got these little tick marks showing up in here. And I'm going to scale these things. I'm choosing to scale them by ones. Now, if you would like to, I'm going to show us on the right-hand side, you can label this as 1, 2, 3, 4, 5. You can label every single one of those if you would like to. Nothing wrong with that. I am also okay with, if you want to, instead of going every single one of them, count out 1, 2, 3, 4, 5, and just write 1 in at the very end. Maybe you'll put in 1 in the middle if you want to also. But I'm perfectly happy with this. It shows me if I'm looking at it, okay, how did you label this thing? Well, if the second one's 2 and the fifth one's 5, okay, you went by 5s, I can handle that. That's perfectly acceptable. And then we need to make sure we do the exact same thing on the opposite side. So if we do -1, -2, -3, -4, -5, I'm just going to put -5 at the end here. So that amount of labeling, even if you didn't have that 2 in there, that bare minimum that you need for creating a number line for yourself. And I'm perfectly happy with you doing that as part of your showing your work on the test. Nothing wrong with that. Now, actually plotting this thing using our methods that we have. So we are working with a less than, which means that when we are going to plot this thing on this number line, we are going to use either an open circle or parentheses to plot this thing. And I'm going to plot this in blue just for the sake of it being a different color. So I need to find where -2 is on my number line. So I'll start working with this with an open circle because I think that's a bit easier to see visually. So an open circle at -2. And now I want all x values that are greater than -2. So is that going to be everything to the left, going more negative, or everything to the right, going more positive? And it's going to be everything to the right in this. So some people have different ways that they like writing this out for themselves. And it's kind of dependent on how you like or want to write this out, but I'm happy with you doing something effective this. From -2, I want all the x values that are greater than that. So something like, here's all of the points I'm using. Just kind of filling that in there in that regard and putting an arrow off to the side. Perfectly fine with that. I've also seen some people, and again, I'm okay with this, just showing you guys multiple methods of it, putting the dot directly above it, and then putting an arrow pointing in the positive direction. Either of those two options are fine. And illustrating, same thing. I'm just going to show you guys that with 5, 5. So I just want to illustrate this again as well with the instance where you are using a parenthesis instead, because it does show up. So again, the exact same problem, just showing you guys another way you can write this thing out. We're working with, again, x is greater than -2. I'm going to be working with parentheses in this instance, so find that -2 on the number line, and I want everything greater than that. So we can write that in as our parenthesis there, and then you can fill it in with that squiggly part, or use just a straight line going in the positive direction. Either of those works great. Make sure when you are going through and working with these, it is abundantly clear that you are working with and writing in a parenthesis or a bracket. You guys would be surprised at how often I see something that kind of looks like a bracket, kind of looks like a parenthesis, and me, who's grading it and trying to give you points, but doesn't know what he's looking at, I can't give you points for it because I don't know which one it actually is. So make it abundantly clear I'm drawing in a bracket, or I'm drawing in a parenthesis, something to that effect. Don't leave that to chance. So looking at our second example, again, we're going to just making sure we're graphing these things properly. We are working with x is less than or equal to 5. So again, I'm setting up my number line. Oops. It does that every now and then. I'm defining 0. Here's my positive direction. Here's my negative direction. So 1, 2, 3, 4, 5. So I'm going to go by ones again. So again, something like this, if you are setting up and creating your number line like this on your scratch work or scratch paper, then you're doing just fine. I can see where 0 is. I can see the positive, negative direction. I can see how you have scaled that number line, and I'm perfectly happy with that. So now I need to find, all right, where is the number that I'm working with? I'm working with 5, okay? And I'm working with x to be less than or equal to 5. So in contrast to the one that we just worked with, I'm going to be working with a less than or equals in here, which means I can work with either a bracket or a closed circle. So I'm going to find 5 on this number line, which is going to be right here. So I'm working with a closed dot there, closed circle. And I want all the values of x that are less than or equal to -5. So it's going to be everything along here on that number line. So everything less than that, less than or equal to that. And again, we can do the exact same thing using a bracket instead. We're just following the same process that we had with our first problem. Again, just illustrating that here. I guess I decided to make an arrow there at the end. That's cool. I guess it would probably be right if I put the right numbers in. There we go. So again, just illustrating this if we were going to use a bracket instead. So again, we're working with x is less than or equal to negative, or less than or equal to 5. 6. Moving all these things around on me. There we go. So I'm finding 5, and I want everything less than that. So I have my well-defined bracket set up there, and then choosing everything that's less than that. So when you are asked to graph these things on a number line, again, you can use the open or closed circles, or brackets or parentheses to make that happen. I am indifferent as to which one you would like to use. Just make sure if you're using brackets and parentheses, you make it abundantly clear to me if what you're writing in is a bracket or is a parenthesis. And again, it is not uncommon for me to look at something that's written down and say, I don't know which of these I'm looking at. And if I have to say that, I'm not going to give you points for it, even if everything else is correct, because I don't know which one I'm looking at there. So make it abundantly clear that you have a bracket or you have a parenthesis showing up. Okay. So I'm going to jump us back to our notes. We'll get into the interval notation here a little bit more. So when we are working with inequalities, we have two main notations that we're used to seeing and we're going to be working with. So we have the instance of inequality notation, which is kind of a more common one that we've already seen up to here, and the one that we use when we're going through and solving problems algebraically. So inequality notation is going to have that greater than, less than, greater than or equal to, less than or equal to, anything like that showing up within it. It's using our forms that we have up here, hence the name inequality notation. So again, this is our more common one that we see. Again, primarily for when we're working with these things algebraically. The ordering absolutely matters with this and the way we have these things set up. From the standpoint of, and I'm going to jump us over and I'll write it in over on the other, on our whiteboard here. I can write this statement, x is greater than 3, two ways. I can write the statement -2 is less than x, which is less than or equal to 7. I can write that two ways. I can write x is less than or equal to 32 two ways. And it all depends on how we have these things arranged and how we have them set up for one another. So we'll jump us over there and we'll take a look at that. And this will also get into when we solve things algebraically where ordering absolutely matters all the more as we're solving these things out. So the idea behind it, that first one that we had x is less than 3. It's that first one that's written out. Or we have x is greater than 3, I should say. Now, this is telling us I want x values, I want all the x values that are greater than the value of 3. So we can write it that way. Or if we completely flip and reverse everything in this problem, it's the exact same thing as saying 3 is less than x. So any x value that we choose, 3 is going to be less than that, or we want x at 3 to be less than any value of x that we choose. So it's two very different sounding statements, two very different written statements, but mathematically they mean the exact same thing. So ordering absolutely matters. One of the biggest ones that I see people do is say, well, I have x is greater than 3. Well, that's the exact same thing as saying x is saying that. We just reverse the inequality in the middle, and that's not correct. Or the other one of, well, what if I just reverse where the numbers are? If I do 3 less than x, that'll work all this into, and again, it does not. The ordering absolutely matters with inequalities. We cannot avoid that. So when you're going through and solving these things out, which we'll get to algebraically here in a little bit, and especially when you are converting these things into interval notation, which we're going to get to here shortly, the order absolutely matters with this. So our other example that we had from the inequality notation, we had x less than or equal to 32. Now I could rewrite that again, similar to what we had above. We could say if I just basically reverse everything in the problem, x is less than or equal to 32 is the same as saying 32 is greater than or equal to x. So two different ways of writing this, but they both mean the exact same thing. I always liken it to, I think this is kind of the classic one, and I'm hoping most, if not everyone, has heard this at one point in time. If you're thinking with inequalities, which way is it facing, which one does it point to, which one's the bigger number. The open part is the mouth of an alligator. It always wants to eat the biggest, largest possible thing it possibly can. Kind of the classic one that always seems to come up when we're going through and learning these things. But it's a good analogy for it. So make sure if you are adjusting and manipulating these things, make sure that alligator mouth is always facing the biggest of the two things that we're working with. The other one that I've heard, I think it's a bit less popular, but you could use it all the same. The pointed part at the end of the inequality, think of it as like a bird beak. And birds eat really small bugs. So the point is always pointing towards the smaller of the two, the small bug of the two. Again, I think the alligator crocodile one's the more popular one, and I'm sure there's any number of other ones you could find out there, but kind of some silly ways to keep track of that and remember it for yourself if you need to. So now we get to the part where how are we going to be setting these things up using interval notation? So we'll use our two examples that we have here because it's very important to go through those. So the way I would always think of interval notation, we're always going to have a lower number. Think of it as kind of our boundaries, as it were. We're always going to have a lower number, and we're going to have an upper number. The lower number always has to go first. The larger number always has to go second. And the idea behind this, and I think interval notation works really great to get a visual for this thing, is we're going to be listing these things. What's the lowest number? What's the largest number on an inequality or on a set of values that we've been given? So looking at our first example that we have here, we have x is greater than 3. So we'll do a really quick number line of this. So -3 and I've got +3. So written on a number line, x is greater than 3, so I have an open circle. Actually, I'm thinking this isn't showing up too well. I'm going to try red for this, see if that works a bit better. There we go. So I have that. So I'm looking at this and I'm saying, okay, if I'm going to translate this thing into interval notation, if I'm looking at this on a number line, what is the lowest value that I have been given, the lowest value that I'm working with? And in this case, it's just going to be 3. So with interval notation, we're going to write this thing out, lower value first. And then what is the largest value that we find on this interval? Well, we have an arrow on the right side here. And that tells us that that thing is going to go on forever. So what would be the mathematical equivalent of being able to say something goes on forever? Well, that's going to be infinity. So what range of values am I using? I'm using everything greater than 3 onto infinity. Now the last part with this is we need to fill in on both sides of this interval notation. Am I going to be using a bracket or am I going to use a parenthesis? Well, for that number 3, we already have a giveaway in the problem that's been given to us. We're told greater than. Greater than corresponds with using parentheses when we are graphing this thing on a number line, so we're going to also use parentheses on that part of our interval notation. And now infinity is one where we are never going to be able to actually ever reach the number infinity. So this means that regardless of what the other side is, we will always, always, always have parentheses set up around wherever the infinity is in our problem. And there we have our, our inequality notation and our corresponding interval notation that goes along with it. And there's nothing wrong when you are asked to write these things out in interval notation, nothing wrong with making this quick visual for yourself to help you out with that. I think it's very, very helpful if we're learning there as we're going through and learning how to do this. So let's take a look at another example. If we have, if we have x is less than or equal to 32. So again, we'll draw a number line, just to have a visual of it. You guys do not need to do this on yours all the time if you're comfortable just translating these things otherwise. So I'm saying that my intervals to go by 16s because I don't want to have to write out a bunch of these things. So I'm told x is less than or equal to 32. So I can include 32. I'm saying here is my dot at that, and I want all x values less than or equal to that. So all of these things in here. Cool. Separate these out here. So now I want to translate this into interval notation. So I'm asking myself, what is the smallest or what is the lowest x value that I am given? If we look on the number line, what is the leftmost number that I have? And as I'm seeing, I have an arrow that's showing up on the very end on this one as well. So if I'm traveling in the negative direction for as long or as far as I possibly can, what would I theoretically reach at the end of that? And the answer would be negative infinity. We're not reaching positive infinity because, again, we are working and going in the negative direction. So my leftmost number, my lowest number I could have would be negative infinity. So as we're moving left to right then on the number line, what is the greatest number that I could reach? What's the largest value I could get to? And that's going to be 32. So we can think of it as our lower bound and our upper bound also. It's another way you could think on it. Now again, infinity, whether it's a positive or a negative, we will never actually reach that point. So on this part of our interval notation, I'm going to have parentheses. You're always going to have that. You can always default to infinity and negative infinity, parentheses, every single time. Looking at 32, am I going to have a parenthesis or a bracket next to it? And the way we determine that, right here. We are told x is less than or equal to 32. Less than or equal corresponds to using brackets. So we're going to put brackets around that right side of the equation, or our interval notation. And there's nothing wrong with having a bracket on one side and a parenthesis on the other if the problem dictates that we do that. Nothing wrong with that whatsoever. So these would be two examples of writing from inequality notation into interval notation. Now there was another one that's written in there, and it's a bit less common in this particular section that we're working with, but I think it's worth going through all the same. We had negative 2 is less than x, which is less than or equal. Better version of that. Less than or equal to 7. Now, if we were to translate this thing, because it's currently written in inequality notation, and we wanted to translate this into interval notation, we'll do a quick number line. Again, if you are asked to write these things out as, or just translate these into different intervals, you do not need to do this number line every single time. I just think the visual of it is very, very helpful. So I'm going by 2's here. And again, this is all I really need to see to know how we're working with this. So I'm plotting these two parts we have here. I have negative 2 is less than x. So I have that less than. That means I'm going to be using an open circle or parentheses. So I'm going to plot that. I'm going to use a parentheses here because I think it's going to be really helpful when we get to our interval notation. So x is negative 2 is less than x. So that means I want everything greater than that. and then x is less than or equal to 7. So 7 shows up right about here. I'll make it abundantly clear that that's a bracket. And then I'm going to have x is anything in between these two. So we now have our visual of this thing. So translating this into interval notation, again, I'm trying to figure out, firstly, what is the smallest value that is presented to me? And the smallest value is that -2. So my lower bound is going to be -2. What's the upper bound, or the largest value that I'm working with on the number line? That's going to be 7. And now I need to determine, am I using, looking at the lower bound, looking at -2, am I going to use a bracket, or am I going to use a parenthesis? And again, if we do not write the number line for ourselves, which you don't have to do, the inequality is the giveaway. It's a less than corresponds with parentheses, so I'm putting a parenthesis around that one. Same thing with 7. Am I going to use a bracket or a parenthesis? I look to the inequality. I'm seeing less than or equal to. That corresponds with utilizing brackets, so I'm putting a bracket around the 7. I have this thing written out in interval notation. So I am hoping it's abundantly clear, but I'll reiterate this all the same. The ordering absolutely matters when you are writing these things out, whether it's written out in the inequality notation, like we have at the very beginning of these problems, and all the more when we are working and translating these things into interval notation, like we have here, these examples. So for interval notation, it is always lower number on the left, largest number on the right. You cannot deviate that or deviate from that in any way, shape, or form. If you do, you are getting a wrong answer. This also corresponds to infinity and negative infinity. I have seen numerous times people put negative infinity on the right side of interval notation. Negative infinity is the lowest value you could theoretically reach. Why would it be the greatest number? I don't have an answer for you on that because it isn't. So make sure when you are going through these and you're saying, okay, I'm going to have an infinity showing up. Is it a positive or is it a negative? And where is that going to go as you're setting up your interval notation in that regard? The order absolutely matters. You cannot just rush through and say, I'll write it there, I'll write it there. You can only do that if you want to get potentially wrong answers and lose points. Let's put it that way. Okay. So that is our general idea of working with our interval notation and translating back and forth between our two forms that we're going to be seeing. Again, this third example that went through over here, not going to be as common with what we're doing in this class and these problems specifically, but it is worth seeing at least once for now because you will work with this later on in future classes. So I'm going to jump us back to our notes. And we're going to go through solving and working with inequalities algebraically. Now, a lot of the previous rules, or pretty much all of the previous rules for solving linear equations are still going to apply here. We're still going to be able to add, subtract, multiply, and divide both sides the exact same way that we've done in the past. We're still able to, if we're looking at it down here, if you're looking ahead on some of these problems, we're still able to have instances where we can get rid of fractions the exact same way as we've done in the past. The big difference that shows up, and I'll go through this with our first example. When we multiply or divide both sides of an inequality by a negative value, the inequality in the middle must change its directions. It should be noted this doesn't change the type of inequality, it just changes its direction. So a problem that originally was greater than it's going to become less than. It does not become less than or equal to, it just becomes less than. It just flips the direction of that inequality. So again, I cannot emphasize this part enough. When we multiply or divide by a negative value, it has nothing to do with if we add or subtract from both sides. It is only if we multiply or divide both sides of an inequality by a negative value. So from here, after we've gone through that and written things out, then we end up writing our answer, our final answer, either as in its inequality notation or in interval notation, depending on what it's asking for. So like for instance, that we have here, right? Your final answer in interval notation with fully reduced fractions. Okay, so we're working through those there. Now I'm going to go through, we have 4 examples here. I'm going to go through most of these. We've got some really fun stuff that shows up with number 4. If you're looking at something, what's that R? What does that mean? We'll get to that. Fun stuff happens there. We'll go through a couple of examples with these to see what those look like. So I'll jump over to our Blackboard, but these are the 4 examples that I am referencing, and we're going through those over there. Okay, so our first example that we have, zoom this in here a little bit. There we go. So we are working with, scroll this down, we are working with negative 4x plus 1 is greater than 13. Okay. So now, again, all of our previously established rules for adding, subtracting, multiplying, dividing are the exact same here. We only have that stipulation of when we are multiplying or dividing both sides by a negative number that we need to do extra stuff with it. So I want to get this 4x all by itself, get the variable terms by themselves on that one side. So I'm subtracting 1 from both sides. Again, I am subtracting 1, which means that the inequality does not need to change directions right now. From here, I do not want negative 4x to be greater than 12. I want just x greater than something like that. I want to get that x by itself. So I'm dividing both sides by that negative 4. So this negative 4 divided by negative 4 cancels out, and I'm left just with x on the left side. On the opposite side, I have 12 divided by negative 4. Positive divided by negative is a negative, and I get 3. Now here, I divided both sides by a negative number, which means I need to flip the inequality in the middle to be facing the opposite direction, just like that. So now I can't do anything else this thing. I have x is greater than or less than something, and I have an answer. Write your final answer in interval notation with fully reduced fractions, okay? So I want all x values that are less than negative 3. So translating this thing over, what is the theoretically lowest possible x value I could use? Well, the lowest value would be negative infinity. So my lower bound in interval notation is going to be negative infinity. I want that x to be less than negative 3. So negative 3 is going to be the largest possible value that I can have. Again, the way the inequality is facing, it's the alligator. It's trying to eat the largest value. You can think of that as another way of remembering these things potentially. So now I need to put brackets or parentheses around this thing. Well, negative and positive infinity will always have a parenthesis. You can always default to that. What about negative 3? Is it going to have a bracket or a parenthesis? Well, look to the inequality. Say less than. It tells me I'm going to be using parentheses. And so we have our final answer right here. Now I'm going to illustrate with the same problem why we end up needing to flip our inequality in the middle here, because it's not particularly clear as to why. I'm going to go through and work through this problem using a slightly different method, but it will get us to the exact same answer, and it should highlight why we need to flip this thing. So working with the same problem, just put in 1 here. So alternative method. So we are starting with negative 4x plus 1 is greater than 13. So let's say instead we say, okay, I don't want to work with a negative 4x. I want to work with only positive values in front of my variable so I don't have to worry about flipping the sign in the middle. This is also something as to why I would recommend you always eliminate the lowest variable term on both sides, so you don't have to keep track of and remember this all the time, which is nice. We'll get to that in a later example here. So instead, I'm going to add 4x to both sides, which you are perfectly okay with doing. Again, I'm adding here. And yes, I have things canceled, but because I'm adding, the sign in the middle is not going to change its direction. I say, okay, well, I've got my positive 4x on the right side. I want to get rid of that 13. I'm going to subtract 13 from both sides. And again, I'm subtracting. I'm not dividing or multiplying, which means the inequality stays the exact same. Faces the same way. If I can get these inequalities written correctly, that'd be fantastic. There we go. A bit better. And now from here, I don't want 4x, I just want x. So I'm dividing both sides by a positive 4. Remember, we only flip the sign if we multiply or divide by a negative value. I am dividing by a positive value here, so the sign is going to stay the same. The direction of the sign, I should say, is going to stay the same. So now I have negative 3 is greater than x. So if you wanted to rewrite this, so we have our variable on the left-hand side, which you're welcome to do. Again, just make sure that the inequality is always facing the larger value. The alligator wants to eat the largest thing possible. And we get x is less than negative 3, which is the same thing that we got over here. So we could translate that back into the inequality notation, and then we get our answer there. So this is kind of the, you could think of it as an informal proof, as it were, as to why we need to flip that inequality in the middle when we're going through these things. Okay. So I'm going to go with our, we'll go with our third example, because I do not want to take too long lecturing on the exact same thing on this. We'll go with our third example, and then we'll get to the really fun but weird fourth example. So example 3, we have 5 times the quantity x minus 4 is less than 3 times the quantity x plus 1 minus 8. Okay, so I'm going to treat that inequality in the middle. Again, we're treating it like it's an equal sign unless we multiply or divide by a negative value. So I'm going to simplify the left side of this equation. I'm going to distribute that 5 through. I'm going to get 5x minus 20. I can't simplify that any further, so I'm going to leave that there. On the right side, I'm going to distribute the 3 through. I'm going to get 3x plus 3 minus 8. And I can simplify this a little bit further. I have 3 minus 8. I get minus 5 showing up. Everything else isn't changing, so I'm just going to bring that down. Now, I've mentioned this, those of you that had me in previous classes, I did mention a hint, and this is another reason why I recommend this. If this step, we want to get our variable terms all by themselves on one side of the equation. Now, it really doesn't matter which of these you eliminate. You can still get the same answer either way. However, If you do not want to have to worry about, do I multiply and divide by a negative, and then I have to make sure I flip the fraction, not the fraction, the inequality in the middle correctly, this is where look at the two variable terms and eliminate the lower valued one, the smaller of the two. If you do that, you will never have to worry about flipping the inequality by doing multiplication or division by a negative value. It will automatically go away, and you will never have to deal with that. So in using that hint, I'm going to get rid of the 3x on the right-hand side because that's smaller than the 5x on the left-hand side. So my results, I'm going to get 2x minus 20. Oops. Less than negative 5. And then I'm adding 20 to both sides. Two x is less than, what's it going to be, 15? And then from here, I divide by 2. I am dividing by a positive, so the sign doesn't need to change. Or changes directions, I should say. And I'm getting x is less than 15 over 2. So now translating this thing into interval notation, what is the lowest number I could have? Well, that's going to be negative infinity. What's the largest number I could have? Well, it's going to be 15 over 2. Then fill in the brackets and parentheses accordingly. So again, infinity, always parenthesis. 15 over 2, so going to be bracket or parenthesis. We have our giveaway right here. I'm told it's less than, so I'm going to use a parenthesis with this. And we have our final answer right here in interval notation. Now we're going to get to the weird example that shows up, because I think this is absolutely worth seeing, because how do we make sense of this? What does this look like? Weird stuff shows up. It's also really fun, I think. So number 4, we're going to work through this thing as if we don't know it's going to be a weird answer. So we have this guy here, making sure I'm translating this thing over correctly. Okay. And again, I'm solving this thing just like I'd be solving any other equation up to this point in time. I'm going to simplify the left side of the equation, then I'm going to simplify the right side equation of the equation, then I'm going to start for inequality, I should be saying. And then we'll start moving things back and forth. So we have 8m minus 28 plus 2m. So this negative 2 is distributing through. Combine like terms, I'm going to have 10m minus 28. And then I can't do anything else from there. Okay. So I'm bringing the inequality down. I have not added, subtracted, multiplied, divided anything to both sides, just doing the simplification. On the right side, the 7's distributing through. We're getting 7m minus 28 plus 3m. Combine like terms. And we're getting 10m minus 28. Now, here's where the weird stuff starts showing up. In this line of work, we're noticing the left side is the exact same as the right-hand side. If you're not seeing that, you didn't see that originally, that's fine. Let's say you went through the rest of the process. Just illustrating that here. So we subtract the 10m's from both sides, and we get negative 28 greater than or equal to negative 28. So this would be another step where we should be seeing, oh wait, that's something interesting is going on here. If we still don't see it, which is fine, let's say we add 28 to both sides. 0 greater than or equal to 0. And here is the last part where it should become abundantly clear that we have the left side of this inequality is equal to the right side of this inequality. Now, if we remember, I believe it was 2.4, we worked with conditional equations, identities, and contradictions. So we have the same possibilities showing up here with inequalities, except now we just have some different ways of how we're going to write out our answers to this. So we're told, okay, well, I want to write this out in interval notation. So on what interval, we can look at it, we're actually going to look at it on our the first instance that this shows up. I think it's a bit more clear in that regard. So we're asking ourselves, if these two things are identical, then on what interval of m values is 10m minus 28 greater than or equal to 10m minus 28? Essentially, where is this equation greater than or equal to itself? You might think, well, okay, that's kind of a weird way of phrasing that. Where is something greater than or equal to itself? If it's equal to itself, it's going to be every single value of m that I plug into that. And you're 100% correct in thinking that. So translating that into interval notation, that would be negative infinity to positive infinity. The other way that we write this out, and this is a more common one that we see showing up, is what I would kind of refer to as this double R. And what this represents is the set of all real numbers. It's essentially a shorthand way of writing negative infinity to positive infinity. So if you were going through and you are, and you are entering your answer into WAMAP or anything like that, and you put in negative infinity to positive infinity, and it says the answer is wrong, look to see, because there should be a setting on there that will allow you to put in a double R. That's kind of what I referred to with that thing. It might also allow you to enter it in as a boldface R. But either way, it represents every single real number that's possible, which for this particular instance is our answer. Because where is something greater than or equal to itself? Well, it's going to be equal to itself everywhere, so any number you plug in will make this statement true, which is really nice. Now let's go with an instance where we have a slight deviation from this, but a monumentally different problem or answer altogether. So alternatively, I'm going to write this thing out. And if we went through our steps, we're going to find that we get to 10m minus 28 is greater than 10m minus 28. That's better too. Okay. So as we're seeing here, the only thing that's changed is the inequality in the middle. So instead of being greater than or equal to, we just have greater than in our alternative example. And it's going to be really amazing here how a single line is going to fundamentally change our answer to this. So if we were to work through this, we work this whole thing down and we find where is 10m minus 28 greater than 10m minus 28? We say, okay, well, based on the problem that we just did, based on our thinking of this, the left-hand side of this inequality is always equal to the right-hand side of the inequality, no matter what you plug in for m, and that is completely true. However, for this problem, we are being asked, where is 10m minus 28 greater than itself? It's kind of a weird way of asking that. Where is 10m minus 28 greater than itself? Kind of think on a little bit and say, okay, well, it's always equal to itself. So how can it be greater than itself? And exactly. So when we have something like this showing up, there is actually no solution to this. It's impossible to find an answer to this thing. The alternative way that some people write this out, and I don't know if WAMAP shows this up or not, or has this show up or not. The other one that shows up is using this symbol, which is the set of, or the empty set. There are no answers to this thing. So you are welcome to use written out like this. You're welcome to write in no solution. And again, WAMAP I think is a little bit weird on how it has this set up and writes this out for itself. Sometimes it has no solution show up. Sometimes it has the empty set show up for the final answer, or it's an option to. And it goes back and forth on that front. So for anyone who is in the habit of writing your zeros like this, you need to get out of that habit now, because there's a difference between 0 and the empty set of numbers. These things are not equal to one another. They're very, very, very different statements. So if you are writing it like the version on the right over here, you're writing a set of values. If you're writing it like this one over here, you're writing the number 0. So be aware of that as you're going through and solving these things. What is it doing here? Oh, just select and delete it. Okay. So be aware of this instance showing up that we have right here. When we get to the point of seeing, oh, the left side is equal to the right side, that's the giveaway of I'm going to have infinite solutions or I'm going to have no solutions. And again, it all comes down to what is that inequality in the middle? Is it have that equal to in there? Because that's going to be a big determinant for our final answer. Okay. So the last thing that I do want to reference is if and or when we get to story problems with these things. So if you are looking for some hints or some ways to translate problems that we will have showing up from English into algebra, page 280 in the textbook has a really good list of ways that we can translate, or we see something written out in English and we translate it into greater than, less than, greater than or equal to, less than or equal to. So some really good vocabulary in there to take a look at. And you can also reference that English to algebra page that is in our useful math files section on our Canvas site. And it does have some tips for translating English to algebra with inequalities as well. Because you can and you will be referencing and using that on the homework. You can and will be referencing and using that on the tests. Knowing how to translate these things back and forth is vital. So take a look at that page, take a look at the page that I provided for you guys. Look up and write down and memorize those buzzwords for yourselves. They are absolutely critical when translating these things back and forth. And a lot of people just try again. They just read through it once. Oh, it sounds like it's going to be this, and they write it out. If it hasn't been made abundantly clear that the direction and the ordering of things with this type of these types of problems matters, it will become abundantly clear when we start losing points for not doing it correctly. So take the extra time to look that stuff up for yourself and write that setup correctly from the very beginning, so you don't have to lose points to learn that lesson down the road. Okay. So this is everything for the 2.7 and interval notation sections of this class. So I'm going to end the recording here. I'll take any and all questions that you guys have, because we've got plenty of time left, regarding any of this material, and then I'll open it up to any homework questions that you guys have as well.